People like Frei Otto have a kind of a longevity in terms of ideas, because these ideas were very avant-garde at the time and very progressive. And so therefore, although as 40 years ago, they still are very refreshing.
As our work matures, we are much more in the footsteps of Frei Otto. Whereas before, we were radical and new, but in retrospect, compared to Frei Otto, perhaps superficial.
The biggest enemy of building is man.
Frei Otto has shown us how it could look like if somebody is really doing it as an artist, not just as an engineer or an architect, but as an artist.
He liberated architecture from kind of square and rectangular kind of forms to really make forms which are in response to natural forces in nature, so with a minimum amount of material.
We can study the nature so that we can be a part of her.
He brought together engineers, architects, biologists, and the most different fields that even were not connected at this time with architecture.
I am also a writer. You could say also a sculptor. You can tell me also as a philosopher, a painter. I am nothing.
Frei Otto's work in tensile structures is staggering. He's really the father in so many ways.
Frei Otto, spanning the future. Over half a century ago, architect and engineer Frei Otto became world famous as a pioneer in the design of tensile structures. Born near Chemnitz, Germany in 1925, Otto's life story is set against the sweep of European history.
I raised in Saxony. My father had a beautiful workshop with a large ground, and I raised up with many animals of all different kinds, sheep and pigeons and chickens. And my mother was especially favoring nature, so that's not a problem for me. I don't know a human being who has not interest in nature. My father was a sculptor. My parents have been members of the German Werkbund. This was a driving force in the 20s for modern architecture. Mies van der Rohe and Walter Gropius have been directors of the Werkbund. And so I was just in the picture of the new movement in architecture as a young man.
The tragic events soon to unfold would derail the development of modernism in Germany. Beginning with the rise of the Nazis in the 1930s, their ultimate defeat in the Second World War in the 1940s, followed by the reconstruction of Europe in the 1950s and 60s. While studying architecture in Berlin, Otto, at the tender age of 17, was drafted into the Luftwaffe, becoming a pilot.
I have seen whole cities burning. as a pilot flying over the burning cities, especially the city of Munich, the city of Ulm, and also partially the city of Stuttgart. To talk on those things, to learn what you could learn from a war, is very important. The strongest first semester for a student of city planning and architecture is to see a burning city. You will never forget that what generations have built and made and developed could be in a few hours destroyed. The question is still the same question since after the last war. What you have to do to survive. Yes, my architecture is an architecture of survival. Very simple. To survive also with all what we are doing.
Captured in 1945, Otto became a prisoner of war in France. While imprisoned, he began to create makeshift tents out of sheets and blankets. The need for shelter in a circumstance of material shortages would be the conceptual underpinning of his life's work.
I must say the philosophical aspect of my work, coming of course out of the 20s of my family, is to make not only a new kind of architecture, to make another architecture. Under Hitler it was a very strong, heavy architecture. And I, as a young architect, wanted a new kind of thinking, real new kind of thinking.
After the war, Otto studied briefly in the United States. While in the U.S., Otto met with, among others, Erich Mendelsohn, Mies van der Rohe, Richard Neutra, Frank Lloyd Wright, and, most significantly, Buckminster Fuller, a fellow traveler in theoretical structural engineering. Returning to Germany in 1952, Otto completed his studies at the Technical University in Berlin and established his practice. Frei Otto was awarded his first significant commission just a few years later, when he was hired to design structures for the 1955 Federal Garden Exhibition in Kassel. The tent was executed by L. Strohmeyer and Company, a firm that since the late 19th century had made tents for circuses, festivals, and for the military. Otto worked directly with Peter Strohmeyer, then the head of the company. Together they developed a new material, membranes pre-stressed via embedded cables, which maximize the stiffness of the fabric. With the three structures at Kassel, the Music Pavilion, the Mushrooms, and the Butterfly, Otto established his reputation as being chief among the pioneers of tensile architecture in Germany.
These have been a new kind of tent structures using membranes. And I was very lucky to head in the tent firm Strohmeyer. Strohmeyer was in this time the world-leading firm in tents.
Together with Strohmeyer, he made the design, Strohmeyer built it. Then there was a development of tent buildings, of membrane structures. And then with Frei Otto, he started to develop a much more sophisticated way using membranes for architecture.
The castle tents led directly to those built for the next Federal Garden exhibition, held in Cologne 2 years later in 1957. For Cologne, Otto designed 4 structures: the entry arch, the hump tent, the peak tent, and, most significantly, the dance pavilion, which was completely surrounded by a fountain. The dance pavilion, though intended to stand for a single summer, has been retained to the present day, with its membranes having been periodically refreshed.
But his structures were remarkable at the time, particularly the contrast of these super light, dematerialized, translucent surfaces, which span quite large spaces, compared with the heavy stone structures.
What really impresses me the most is the force of innovation behind his thinking, both in structural geometry and materiality.
But it was congenial to some extent to the ambitions of the 1950s modernism, which picked up from the 20s, for a light and dematerialized architecture. So the work of Mies van der Rohe comes to mind, the work of Egon Eiermann, but they did this with orthogonal systems, with steel and glass construction, and Frei Otto just was beating these efforts by orders of magnitude in terms of dematerialization.
Also in 1957, Otto became involved in the design for a number of structures at the Interbau in Berlin, which was an international architecture fair. His most important contribution to Interbau was the Garden Café and its complement of 4-point tents. The roof of the Garden Café was made of a single piece of Perlon fabric, held up by only 8 masts. The Garden Café became an international sensation. Otto's theories about the portability of tensile structures would be tested when the hump tent of the Garden Café was moved in 1958 to a man-made island in Lake Zurich.
This combination of the hump tent in the water, in the park area, was a sculpturing highlight.
And these little things are much more impressive than the huge ones, you know. Even if the huge ones are based on the little ones. Because the knowledge taken from the little ones, experimental small buildings, have been the basis to build the very big things.
Based on the knowledge he had acquired creating these tents, Otto designed a pair of monumental tensile structures and a number of smaller ones for the International Garden Exhibition in Hamburg in 1963. There was the enormous wave hall and the membrane hall, which was even larger. The forms of these structures were theatrical and lyrical, qualities that were heightened by the equally dramatic smaller accent structures, the 4 cross-wave pavilions. The culmination of this first phase of Otto's tensile experiments were the Niège rock tents he created to serve as the roof of a pavilion designed by architect Marc Sauguet for the Swiss Regional Expo of 1964 in Lucerne. The Niège rock tents represented a breakthrough for Otto in his quest to span wide areas with tensile structures. and the Liège rock tents would lead directly to his first truly international triumph, the German Pavilion for Expo 67 in Montreal, which featured the rich vocabulary of forms he'd been developing for over a decade. Otto began work on the pavilion at the Institute for Lightweight Structures in Stuttgart. Initially, Otto had the faculty and students at the institute create a full-sized model of one of the tent structures that he envisioned using for the pavilion. When all the necessary testing had been fully carried out, this large tent was converted into the permanent home for the Institute for Lightweight Structures, which is still standing in Stuttgart. Using a series of physical models, Otto conceived of a megastructure for Montreal, with the German pavilion having been imagined as a lyrical clutch of assembled tent forms, their specific shapes and relationships determined by a dialogue between the structure and the natural forces. Otto combined the dominant tensile forms with a partial interior grid shell hidden from the outside by the tents. Otto employed vertical steel pins anchored into the ground, which were then draped with a wire mesh, the entire structure being ultimately clad in a translucent fabric membrane. Constructed on a series of islands in the St. Lawrence River, Expo 67 became a showcase for cutting-edge ideas in engineering and architecture. This made the selection of Otto as the designer for the German pavilion a logical choice, since at that time he was the most revolutionary designer in Germany.
I was known as the young tent builder, and I was very happy that I was asked to build this building. I made several model structures and tent structures to make this pavilion.
In one way, Montreal represented kind of like a break, because it was built, designed on Frei Otto's theory of building models. And at the same time, Montreal was really the first building that was built based on physical models, but also based on computer theory.
Pavilion was pretty large. By 100 meters, this time was unknown to have a cable net or a similar structure. Now, it was steel cable net. The first time on a large production with a cable thickness of 12 millimeter. Without Peter Strohmeyer, the tent builder, I never could have done this pavilion. I was very happy to have the best producer and scientists of tent buildings behind me.
Expo 67 was presented from April to October of 1967, and it caught the popular imagination of the world. There were the mini-skirted hostesses at the British Pavilion. There was the unveiling of a new Alfa Romeo sports car called the Montreal. There was a live broadcast of the Ed Sullivan Show. One of the main attractions was the open-air monorail that took visitors throughout the site. And setting the architecture press on fire was Habitat, a radical high-rise made of stacked, pre-manufactured elements by Moshe Safdie. But most of all, there was Buckminster Fuller's geodesic dome for the U.S. Pavilion. Otto, who referred to him as Bucky, was a close friend of Fuller's.
I loved him, and we tried many things, and this was our real relation. We both did think free.
Inherent in doing more with less is someday you might be able to do so much with so little per given function. You might be able to take care of all humanity at a much higher standard of living than anybody ever known.
Look, one sentence of him: I could build a gridshell around the earth. He said once to me, but he expected that I said to him, you could not do it. Maybe with a satellite of 100-meter diameter or 1 mile diameter. But you are wrong, you could not envelope the Earth. And 2 years later, I met him in Berlin. Then he did come to me and said, you are right. I cannot do it. I have understood the limits of structures.
So it's a minimum system in the universe, and only a triangle holds its shape. And I wanted to have a word, I wanted to define structure.
Bucky Fuller was kind of pioneer in lightweight construction, and when he asked Norman Foster once, what does your building weigh? And Foster was kind of dumbfounded, couldn't answer the question. But I think Frei Otto would have known, and most probably did the lightest buildings relative to surface coverage that was ever created up to that time. I consider Frei Otto to be, in the end, much more profound and important than Bucky Fuller. Because Bucky Fuller stayed, in a sense, with Platonic geometries and didn't liberate form to the extent. He was pioneering the sense of being anti-classical in material translation with his geodesic domes, and he had a geometric knowledge and innovation. But what Frei Otto is doing goes beyond geometry. It is this material computation which allows form to find itself, tying in with the infinite or endless forms of nature. Whereas Bucky Fuller stayed with the Platonic solids, if you like, of classical architecture and didn't go beyond that.
He has built only a very small number of buildings. But he has his influence was intellectually, philosophically, and not in that way that he has created examples which the rest of the world, the rest of the architects and engineers should follow.
But what is so unusual about these tensile structures is their scale and their free form, the capacity to not be constrained to symmetry or one single cone like TENS used to be, but to have multi-pylon complex networks and resolve these complex balance of forces. That makes them so unique and beautiful, and then he translated that into the much larger project at the Munich Olympic.
Even as the finishing touches were being put in place on the German pavilion at Expo 67, Otto received the commission for what would be his most important undertaking: designing the complex for the Summer Olympics to be held in Munich in 1972. The Olympic Village competition represented the most sought-after commission in Germany since the end of the Second World War. Many of the most prominent architects and engineers then working in Germany were involved in this ambitious project. Otto teamed up with architect Günther Behnisch to create the master plan. Otto then reassembled the team of colleagues he'd been working with for years. There were the students and teachers from the Institute for Lightweight Structures. There was Peter Strohmeyer, whose family business had been making tents since the 19th century. And there was longtime Otto collaborator Fritz Leonhardt, a structural engineer, who brought in Jörg Schleich and Rudolf Bergermann, and there were many others. The site chosen for the Olympics was redolent of modern history. The area at the edge of the city, now known as Olympia Park, is covered in hills sculpted from the mounds of rubble moved there after the heavy Allied bombing of Munich. The cutting-edge design of the Olympic Village, rising as it did on these evocatively fallow grounds, eloquently expressed the key goal of the Games, to recast Germany internationally as a peaceful and modern nation.
When I did work for the Olympics, there was no change in personality. It was nothing new for me. It was using the given knowledge in this time.
I was about 15 when the Olympics in Munich took place, 1972. And the competition for these Olympics had been done between several people. My father, Günther Benisch at the time, Benisch and Partners, together with Frei Otto. And what was interesting was a very holistic approach. The engineering, the landscaping, the sports, the architecture, it was all one thing.
But there was for many years always a kind of conflicting relationship which was maybe a little bit based on jealousy. Like the engineers felt, how come architects get all the credit and we do all the work for them? So, but then eventually they ended up working together very nicely.
We should not forget that at that time they were all very young who were involved with this project and had submitted a competition entry with a structure, an architectural image that never had been done before. It was a very unique approach. The only time something similar had been done was for Montreal, for the German Pavilion, which was similar but in a very much smaller scale. And for me, it was, for all of us, was a very exciting and tense time.
A lot of very interesting collaborations between all these people, you know. So you would find some, like 2, 3, the egos were always there, but they kind of overcome their whatever it is to do a great idea. And that was what's really exciting. I think that the tents and the Olympic site are really stunning because you don't expect it to have such transparency through glass, not just through fabric. That's really amazing.
One of my studies had been the largest span which we can do on Earth for all structures. Any kind of structure has a finite span. Only the tension structures has the largest span which you can do in the world. Compression structure out of stone, you could never do spans of several kilometers or miles. With tents, with cables you can do.
If you scale up structures, something also happens. There's, there's a difference between an elephant and a mouse. It's not only just an inflation of geometry, like the classical architecture thought. They said that a proportional system they can do small, medium, large without changing the proportions. That's one aspect of this, where he went large, he suddenly had huge members, and sometimes it has been kind of criticized or discussed that the lightness he achieves overground is actually achieved by incredible heaviness of foundations underground.
Not so easy to erect a cable net, which high weight. Even if it's a lightweight structure, it's a high weight. The stadium has about 12 or 15,000 square meters, and it has to be erected with a special kind of scaffolding underneath to bring it up before can be pre-stressed. And all these things have to be discussed, and how to put the cladding on it. All these things have to be developed together with the institute group, Frei Otto's group, and the engineers in Munich. We were left gravel and sand. And to anchor a tension force, that's one of the problems in pre-stressed structures. You have to anchor tension forces. Rock is the best ground, and sand and gravel is the worst one. And in Munich, it was a very bad situation for the foundations. All the cables guiding the mast top, they have to be anchored for tension forces. And that was one of the biggest problems, how to anchor high forces, high tension forces in a gravel ground. And it was made with heavy weight. The big edge cable of the stadium, the tension force in it is 4,000 tons. For the normal state without loading. And to anchor 4,000 tons of tension force to gravel ground is only possible with at least 5,000 tons of weight on both ends. They had to build blocks of concrete in the size of private houses, compact concrete, to create the foundation to anchor these tension forces.
What is still magic is the transparency and lightness of the actual membrane, where you have equal spans with an ordinary, for instance, bending beam structure. Not only would you have these huge columns as well, but we would have huge beams and members, while he achieves the kind of dimensionless, nearly dimensionless cable net. So it is super light still, but to feel the heaviness or the forces finally where they concentrate in the pylon, that becomes, of course, very large.
Part of the roofs were designed with computers, computer programs written specifically for these tensile and tense structures. And Frei Otto still worked with his chains, the chain models, physical models.
Actually, there were a lot of people who were kind of critical, or maybe not critical, but more skeptical, because they thought maybe it works, maybe it doesn't work. They were kind of questioning whether it works at all.
I have a particular liking to the Olympic Stadium. As an engineer, I find the inventory of all the tensile structures there to be incredible, right? I can literally find all of the kind of conditions you can achieve in that kind of a structure. And so in that case, in many cases, it's probably one of the best examples of built work where you can go and actually see the actual physical consequence of a specific approach.
His greatest accomplishment is rethinking the way we think about structural forces, in my mind. He envisioned a way to take on ideas about structural stability from the exact opposite. Instead of only thinking about compression, he really brought in ideas of tension and ideas of form-found structures, which are more common today, but at the time of his invention and operation were really quite unique.
This paradigm of parametricism I've been talking about, and where I said Frei Otto is the only precursor to it, we can maybe achieve a multi-author coherence.
The formal approach where suddenly the building form and structure, again, like in the old historic architecture, building form and structure became unified again, not separated. Where it's suddenly possible to form buildings that are with a structural supporting skin. And I would say that this approach, thinking approach, that structure and formal form in architecture are not separate elements, that they should be unified. I think that's one of the big merits of Frei Otto, to really not invent it, but reinvent it again and make it understandable for everybody.
And I'm surprised these ideas were not used more, and not just there, but in other domains, because there were so many congress centers, so many large spaces underneath, and this is, I'm really surprised.
Without a doubt, Otto's designs for the Olympics are what established his place in the history of architecture. However, despite the fact that the Munich Olympics, nicknamed the Happy Games, were meant to showcase a new Germany, the event would be marred by the horrific terrorist attacks on the Israeli team. Olympia Park still stands today, not only as a memorial to the tragedy, but even more so as evidence of the lingering triumph of Otto's futuristic genius. Otto's principal contribution to the field of lightweight structures is in the realm of tensile architecture, but his interest in novel approaches to shelter was far broader. Another experimental building type that fascinated Otto was the grid shell. Clearly, Otto's most important realized example of a grid shell building is the Mannheim Multihalle, built for the Federal Garden Exhibition of 1975.
With the Multihalle in Mannheim, I tried to make a larger experiment in compression structure. The Multihalle was not using tension structure. These are structures in compression. I have done several experiments with compression structures, but the Multihalle was the largest.
A grid shell begins as a flat arrangement of flexible structural members that are laid in a checkerboard or crosshatch pattern. Applying forces along the grid's margins distorts its original rectangular shape, resulting in curved forms.
It was quite fascinating because that is really a building which is exactly following the idea of form finding. Multihalle is actually some very close relationship to most of Otto's work, even cable structures, because the Multihalle is primarily thin glassly curved, which means in both directions the same curvature. And most of his other work is anti-classic, positive curvature and negative curvature. But both were made out of square meshes, which are initially squares and then become rhomboids to become either anti-classic or rhomboids to become synclastic. So there is a very interesting correlation between synclastic and anti-classic. Both of them are made out of rectangular square meshes which are initially flat on the ground and then deformed in space.
Otto chose wood as the material he used for his grid shells, both because of its relatively light weight and because of its ability to bend without breaking.
Wood is a very good material for lightweight structures which are in bending and compression. Some of the aeroplanes of the last war had been completely out of wood. So we used all these structures to enlarge our picture of living and non-living nature.
As he had with his tensile designs, Otto used his time-tested inverted models to find the particular forms he could use. The specific character of these forms was determined through the forces of gravity acting on the suspended chain models. The results of all these experimental models was the monumental Mannheim Multihalle.
There's a history of shell structure throughout history, so they have a kind of historic value because they've been translated from the domes of other, the great churches or whatever it is, and it has a kind of a modernist value because it's also very contemporary.
Compression is much more difficult to build as in tension. Tension is always stable. Compression is very seldom stable. This is the main knowledge of our century.
Though constructed for a temporary event, a federal garden exhibition, the Multihalle is still standing in Mannheim in good, if neglected, condition. Sadly, however, it has been periodically threatened with demolition. Otto's ethically driven minimalism means that he hopes to make as small a mark on the earth as possible. In this light, it's not unexpected that Otto would feel that the 1980 Hellebrun Aviary at the Munich Zoo was his greatest accomplishment. Designed collaboratively with architect Jörg Gribbel, the aviary is barely there, illustrating Otto's unique take on the concept of less is more.
And Frei Otto's work in that vein of less is more is quite spectacular in that the thinness, the delicacy, the intricacy of his design is done with very, very few moves, and it's done with a kind of collaborative and collective sensibility that's quite unique in both premise and in execution. His aviary project is a perfect example where he was able to embrace the function of the building, the necessary performative qualities that needed to happen, and advance his own agendas of structural thinking to find a unique solution that's perfectly suited to it.
It's not like the high-tech, where it's very visible, but how to make it almost disappear so that the building almost floats.
As an architectural element, it's really a building which is very good example of a architecture in response to nature, because it's a very natural form.
Of course, the aviary is what I like my best art building, architectural building. As a visitor, you forget that you enter the aviary. You have water inside and outside. You see fishes. You have a landscape. In winter, it can happen that the aviary is covered by snow. Then you have a tent out of snow. And very thin wires. And it is a large room. A room which is 100 meters long is not small. So you can really walk through.
Frei Otto represents a kind of sophisticated and augmented version of the less is more statement, and that kind of reduction to essential requirements is brought to kind of fulfillment in his work and in these processes. Seems to disappear totally. The only accentuation is around the pylon. There's some kind of need to gather the net and build up strength in the net to then let it meet the pylon. Yeah, but it is beautiful. The aesthetic I would talk about he's bringing forward is an aesthetic of variation, organic variation, like you find in nature. It's an aesthetic of lightness and dematerialization, so the sense of a light footprint.
The aviary clearly represents the culmination of Otto's lifelong interests in reconciling nature with architecture. And the aviary succeeds on both of these accounts. It represents both a brilliant solution to the special enclosure needs of an aviary And at the same time, the novel and expressive modernist shapes of the structure obviously derive from the forms Otto found in nature. Most remarkably, the aviary actually seems to vanish and melt into its natural setting. Strolling along the meandering paths, visitors genuinely experience a walk through the woods. The sights and sounds of nature flow seamlessly from the outside, literally uninterrupted, right through the aviary. In addition to his dual careers as an architect and engineer, Otto was also a lifelong educator. Beginning in the 1950s, he taught and presented workshops at colleges and universities in Europe and in the United States. Soon after earning his doctorate at the Technical University in Berlin, Otto, in 1958, founded the original Institute for Lightweight Structures. In 1964, the institute was relocated to the University of Stuttgart, where Otto had joined the faculty. He served as the institute's director until his retirement in 1990. At the institute, Otto pioneered alternative teaching methods that often relied on experimentation, observation, and actual construction practice.
It's very hard to identify a greatest accomplishment of some very general inventor like Frei Otto. I would say a great accomplishment was the institute at the university in Stuttgart and influencing a whole generation, several generations of engineers towards a very innovative approach to structural design, to architecture and so on.
Well, he was never teaching in the normal way. We never had permanent and regular lectures in our institute.
I was a student in Stuttgart while he was teaching and while the institute was going on. It felt like hippiedom. The institute was full and overgrown with vegetation plant, and scientists looked like hippies. We were the early 80s, we had totally changed our kind of aesthetic sensibility, and this seemed, so that blinded me a little bit about the profundity.
He has an incredible feeling for the flow of forces in a structural system. He can feel what is the best way, without any calculation, feel and describe. It's also necessary to describe it, to communicate to others, which then do a perfect calculation.
He crossed the border between pure engineering, where engineering is pure mathematics science, to a design approach to engineering.
And that was important for me because I was educated as just a simple civil engineer based on calculation. And that is what I had to learn my first time working with him, that there are many other aspects which cannot be calculated.
The Institute of Lightweight Structures has always been very influential since Frei Otto founded it. It developed new methodologies, and this institute actually opened the discussion between the architects and the engineers. Suddenly, engineers were empowered to discuss formally with architecture.
The Institute is still housed today in a tent structure that served as an experimental study model for the German Pavilion in Montreal. Antonio Gaudí, who worked in Spain at the turn of the 19th century, was a key influence for Otto. Gaudí's approach to form finding through experimentation provided Otto with his only modern predecessor.
Of course, Gaudí is one of those men my institute and with my students studied very deeply. We are real knowers of Gaudí's work and admiring it. We even made a repetition of his famous model, which is still in the basement of the Sagrada Familia in Barcelona. But it is a whole story. We could talk hours on Gaudí.
Gaudí was somebody who pioneered the chain hanging models, a kind of early form finding. But Frei Otto systematized and expanded that and generalized that research.
Gaudí, everybody before had to work with the ideal parabolic form. Frei Otto was able to change these forms, create asymmetric parabolic forms. So he carried it further.
Frei Otto looks towards nature, but not from the kind of conventional discourse, which tends to be biomimicry. He looks towards nature to find natural processes and intrinsic physical forces and natural forces that have an essentialism to them.
Form finding is a physical setup apparatus which settles into a form according to the weights and forces and orientation he sets that model against gravity. So it is working with elastic fabrics, for instance, and hanging weights on them, or chain models. Media like soap, where form self-organizes and it's not drawn by hand or invented or preconceived. It emerges out of a physical process. It's just something you let a natural physical process take place, and sometimes these setups are such that they are settling into an equilibrium form. And the good thing about these forms is that they are self-optimizing and equilibrizing relative to the forces. So when he's doing his hanging model, where a form settles, and he's photographing this and freezing this and then inverting it, it is an optimal dome shape. And that could be on a totally irregular footing. So it's a complex, irregular, settled form, like for the Mannheim. But it's ultimately self-optimizing. And when he then flips this over, he has a beautifully reliable shell structure, which would have been impossible at the time to calculate because of its irregularity of form.
And it's tremendous as an idea of a sort of utopian idea about knowledge and the potential of architecture to affect the broader culture and community that we live in. I think that's fundamental to Frei Otto's work, is not just the formal and the functional aesthetic that he derived, but also the social and the pedagogical agendas that he tried to pursue and really make almost open source, kind of accessible to everyone. It really was a vision for a new way of thinking about architecture.
It's the paradigm shift, and that these forms are appealing, attractive, sensuous, beautiful, legible, plays into that, of course. The results need to also convince intuitively and become striking, but they have more depth and they have this kind of lightness, this material efficiency, and that paradigm, I think, is very, very important, which really inspires what we're doing now, can be expanded beyond structural criteria into environmental criteria. Energy, sunlight penetration, water management, where we need to have that similar open-mindedness about morphologies emerging out of these simulations, form-finding processes.
What has re-emerged is through, not only because of computing, but through computing, a lot of these experiments were re-found again.
What I find so powerful about Frei Otto is that his research paradigm can't be reduced to tensile structure. It's a general new way of approach to all architectural and urban morphologies. And I think all that was initiated by this shifted perspective which Frei Otto introduced into the discipline. And that's why I find him so inspiring and so path-breaking.
With the rise of digital technology in the last 20 years, Otto's ideas are more important and relevant today than they were over a half-century ago when he first began to develop them. Otto continued his practice into the 21st century, working chiefly as a consultant. His expertise was sought out by a number of younger architects, including Shigeru Ban, who conferred with Otto on the design of the Japanese Pavilion at Expo 2000 in Hanover. Over the course of Otto's long and distinguished career, he sought not so much to determine the forms of his buildings as to discover them through experimentation. When considering his most important projects in retrospect, it's clear that Otto's work traced a singular trajectory that followed his relentless quest to establish a nature-based architecture. On March 9, 2015, while this documentary was still in production, Frei Otto passed away. However, before Otto died, he had been informed that he was being named the 2015 laureate of the Pritzker Architecture Prize, which was awarded posthumously.
To understand living structures, especially those which are not stable, of those which can move, which can live. We have now the future. The future is not tomorrow, the future is today. And we have to see all these evolution in a whole. And you have a picture of the world of tomorrow.
Otto's contributions to architecture, engineering, and education are ongoing, having impacted his own time, the present, and spanning the future.